So this week, our lab is going to cover fiber identification and classification. This video is going to go through just the basic information we want you to be aware of so you can make proper observations when it comes to your experiments and you can get the most out of it. Things you're going to want to kind of be prepared for is the three things we're going to be expecting from you. One is your Canvas preparation quiz. Make sure you complete that. It goes along with Chapter 2 reading. The second is completing your lab sheet all the way through, and that will be turned in before you leave lab. And the third is you're going to need to transfer some of the information from your lab sheet into your textile fiber report. Reminding you, this textile fiber report is the overall culmination of all of the data that we have retrieved throughout the experiments this semester. So, fiber identification and classification. What we're going to be doing is we're going to be looking at what fibers are located within your textile that you're going to be testing throughout the semester. Some of you have blends, and there's a lot going on. You're each a little bit different, so each of your experiments are going to have different results, which is exactly what we want. We have 4 tests that we're going to be doing in this lab to do your fiber identification and classification. The first one we're going to do is a burn test. Now, why do we like burn tests? Well, one, it's really inexpensive. It's super easy. It's a fast result. We don't need a lot of crazy expensive equipment or supplies. So a burn test, it's pretty good. It's not foolproof, however, and I'll go through some of the faults of burn tests with you in just a moment. But just know that it's one that's commonly done. Now, during our burn test, we're going to be identifying if your fiber contains the properties of either a protein, cellulosic, manufactured, or mineral. And we're going to identify these 4 different characteristics by the way the fiber burns. If your fiber has a protein base, you're going to notice that the flame will actually, it curls away, or excuse me, the fiber curls away from the flame. The fiber will support combustion with some difficulty. It will actually kind of sputter on and off as you're burning, so watch that. When you remove a protein away from a flame, it will actually self-extinguish. There is a specific odor for protein. It will smell a little bit like burnt hair, so be prepared for that. It's very easily crushable once it has, obviously stopped burned and it's cooled down. And there'll be, a little bit of a brittle ash, so look into that. Your proteins are going to be, if you have wool, silk, anything of those natures within your fibers. As far as cellulosic fibers, what you're going to notice is that it will not shrink away from the flame. It heavily supports combustion. It will burn very, very, very fast, and it may not have an afterglow once it's extinguished. It smells like burning paper. Obviously, cellulosics coming from plants, so just like wood would burn or paper would burn, has those similar qualities to it. When you are looking at the ash, it'll be very soft. It'll be a little bit more gray. So you're going to obviously identify, is it cotton, is it flax, is it rayon, if it has those characteristics. When we're looking at manufactured fibers, our manufactured fibers are going to fuse away from the flame, similar to protein, so don't just use that one. Look at all the other characteristics as well. There will be some shrinking and curling. It will ignite before it even gets to the flame. So it just needs to be, in the close proximity of the flame, and it will automatically ignite. So that's a key factor you need to look for. The ash is going to depend on the many different types of fibers. So it's not just the same ash for all manufactured. They're each a little bit different, obviously, because they have different qualities, chemicals, things like that. Once it is done, it's extinguished, you're going to see it's kind of like beaded, very hard, hard molded type bead on the end of the fiber. And, these fibers are going to be your nylons, polyesters, acrylics, things of that nature. Finally, mineral. If you notice that your fiber is glowing within the flame, if it does not support combustion, if there's zero odor, if there is, if there may be a bead, not, that hard black bead, but more of a clear one, then you're going to see that there's a glass fiber. It's very doubtful any of you are going to have a mineral fiber within your textiles that have been provided for our labs. So don't have to worry about that. But in the future, especially those of you in OPDD, this is something you would want to look for within the fabrics that you work with. Now, like I said, there are some limitations to a burn test. The burn test is not 100% satisfactory for identifying fibers. It would be really hard to differentiate between cotton and rayon because they both come from a cellulosic group, so they're going to have similar qualities, similar burn qualities. The test has some other limitations. If there is a finish to a fabric, or a finish that has been applied during some point of fabric construction, that's going to affect the way it burns. So it's going to give you an inaccurate burn result. If there's any, flame-resistant chemicals that have been put on it, that's going to obviously have a reverse effect there. I'm trying to think. A lot of your fabrics you're going to notice have a blend to them. So because it's a blended fabric, the blended fibers may have different results. If you have some, cotton nylon blend, well, your results are going to combat one another. So just be prepared for that. It's something it's going to happen. Now, because of this, especially with the blended fabrics, make sure that you are testing the warp and the filling yarn separately, because with a blend, your warp is going to be different than your filling. So make sure that you are testing the different warp and filling yarns completely separately, and that will give you a better result with your burn test. So now, similar to the burn test, we're going to be lighting some other stuff on fire, and that is going to be with the melt spinning. Manufactured fibers are spun from liquids, and therefore they make these very long fibers. They're not like, the staple fibers that you're going to find within your natural fibers. So they're very long. And so what ends up happening is we can kind of regenerate the melting of these fibers. So this test, what we're going to do is identify if there's any manufactured fibers. During melt spinning, if you are unsuccessful, that means that you have a natural fiber because your fibers are not able to be kind of recreated. What melt spinning is we are looking at, are we able to melt the fiber and stretch it long again to get that long fiber that was originally created. So that's what we're going to be looking for. Again, if you're not successful with melt spinning, it means you have a natural fiber. If you are able to stretch it very long, you have a manufactured fiber. You're recreating what happens when these fibers are originally constructed. But again, just as the burn tests have their limitations with blended fabrics, multiple fibers within the same fabric, or any finishes that are done, you may have inaccurate results. So be prepared for that. That's why we're doing 4 completely different tests to kind of combat all of these limitations that each test or each experiment presents to us. Our next 2 experiments, we're going to get away from the flames, and we're going to do some other things with them. So when we check solubility, we are going to be identifying how your specific fibers within your fabrics adapt to 2 chemicals. One of the chemicals we're going to be using is acetate, and another chemical we'll be using is bleach. There's a variety of chemicals we could use. We use just very basic household chemicals that you're more or less going to be exposed to, and that you'll have more of a real life application to when identifying, the proper uses and handlings of certain fabrics. So generally, a solubility test is most useful when you want to identify generic family classes of manufactured fibers. It can be used to confirm the identification of natural fibers. Many of the solubility tests require special equipment and chemicals. Like I said, we're just going to be doing basic household chemicals, so we'll be able to identify, certain manufactured fibers and certain natural fibers. Again, not all of them are going to be able to be identified, but like I said before, between the 4 tests we're going to be doing, you're going to be able to figure it out. So, for example, if your fabric has any acetate fibers in it, what you're going to notice is that it actually becomes very soluble when submerged into the acetone. Another thing you're going to identify as far as natural fibers go is that if you have either silk or wool within your fabric that you're going to be testing, that when it is exposed to bleach, it will first yellow in color, and then it will slowly start to disintegrate. So those are some of the things you're going to want to look for. Again, if the solubility experiment's not really working well for you, that's okay. We have the other 3 experiments that we do just to make sure that you're able to get all the information that you need. And our final test, which has to do with heat, just no flames, is the thermoplasticity. So with this test, we're going to look at how does your fiber react to heat. Is it easily molded or shaped when exposed to heat? So various changes will occur according to the different chemical compositions of a fiber. The quantity and the degree of heat control will result according to each specific fiber, especially man-made fibers. Some of the results you're going to notice is maybe the fiber gets softer, melts, it chars, it burns. Each one of those has a different degree of thermoplasticity. Excuse me, I don't know why I'm having such a hard time with that today. Your natural fibers are going to burn or they're going to char. Your manufactured fibers are going to usually get really soft or melt a little bit. So the reason we want to identify whether you have any thermoplasticity to your fiber has to do with what kind of heat treatment is acceptable for your specific fibers. Obviously, if you have any burning or charring, that means that you need to be aware of the level of heat that you present when it comes to ironing a fabric or something of that nature. When it comes to, heat setting pleats in pants or shirts or dresses, you're not going to be able to pleat set cotton pants. That's just not going to happen. You're going to have some manufactured fibers within those slacks in order, to have those heat pleats permanently in there. So this is just kind of what the thermoplasticity test is for. We just want to see, are we able to change the shape? Will it maintain the shape? And does having the fiber exposed to heat for a long period of time in a specific shape, will that affect the fiber at all? So again, this is just brief information. You're going to be getting hands-on hands-on experiments or hands-on experience is what I want to say with all of these. And make sure you're looking for the next video, which will go through these step-by-step instructions for you. So, thank you for viewing.